I'm giving an introduction today. This lecture is mainly descriptive, and I'm giving an introduction. This is not something you have to take notes on, okay? So this first 20 minutes, maybe less. Let me see, I don't have a PowerPoint here, no? These first 20 minutes, don't take notes. I am showing on the screen the lecture just because it helps for the video and helps me to remember what I have to say. And I want just to give you some advice in order to get the best from university experience. I'm sure that some other colleagues of mine already gave you some advice, but I want to start by trying to discuss with you what are the qualities and what is the type of experience that is more useful in order to get a satisfactory career, a good job, in order to get a good preparation to prepare you for the job market. And I think that you may find some of this advice trivial, but we are not spending much time. I just want to make sure that we understand each other and you understand why I am insisting on some specific features and some specific topics rather than others. And I make reference to what are called the 21st century skills. And you see that there is a link here to the 21st century skills. It's a Wikipedia link. I anticipate that the majority of my links is to Wikipedia. Wikipedia in English, I traced this type of information. I had some discussion with colleagues because some of them think that Wikipedia is unreliable. I think that in English, Wikipedia is a good reference. Sometimes I found indeed on some topics, some people may say that it's biased, but because, you know, Wikipedia is a community effort. So if there is a mainstream, indeed, Wikipedia may turn out to be influenced by this mainstream. It is, in principle, it is impartial, but of course, it's a community effort. It's modified by people. And therefore, it may happen that it is a bit close to the mainstream rather than close to controversial interpretation, you know.
There is a research that says Wikipedia has less error than I don't know.
Treccani.
An American encyclopedia.
Okay. Yeah, I think so. I think in English it is very reliable. And in the native language, and not native, let's say, in the minor languages like Italian, it's more likely that it's wrong because, of course, because the reliability of Wikipedia is related to the size of the community that checks it. So I think that it's reliable. So most of my links refer to Wikipedia. I found that is indeed useful to teach. For teachers, I think this has been amazingly useful to improve the quality of teaching. Anyway, let's go back. Sorry, I forgot to show you the picture. This is the picture that is included in my webpage. These are the so-called 21st century skills. Of course, you know, it's an interpretation. The fact that they have selected these skills, of course, we could discuss for additional ones, or we may think, depending on the field, that some of them are not very relevant. But indeed, I think it is nice to put attention on this table because they are divided in learning and innovation, digital literacy, and career and life. But actually, some of them are a bit overlapping. So if you look at learning and innovation, critical thinking and problem solving, creativity and innovation, communication and collaboration, extremely important, these 4 points. And let me just emphasize a couple of things. Critical thinking and problem solving. Problem solving is what a person that is looking for an engineer is looking for. So the problem solver. So we want people that solve problems, not people who raise problems. And this is a classical say, you know. And but it is indeed, if you are a good problem solver, you will have a happy life, because I mean, it's really an important quality. Critical thinking, what does this mean? It means that, you know, it doesn't mean that we need to be provocative, but it means that we have to be critical, even with respect to the mainstream. You see that today, for the effect of the increased communication, society is increasingly following the mainstream, which is not bad, because the mainstream usually is the expression of the majority of the people. So it is usually not wrong, not always. Sorry?
Parameter.
It's a parameter, yeah. Usually it's advisable. It is a safe solution, let's say. Sometimes it got wrong, because you know that consensus, if you look at history, there were phases in the history where consensus was supporting terrible interpretations. But, I mean, critical thinking means precisely not to just follow the mainstream, but to pay attention also to alternative interpretation, to be independent, to create your own opinion, okay? And this is something that I tell you, it is very evident for an experienced person if they are speaking with a person who is just following blindly the mainstream, or if this person has elaborated its own opinion. This is something that you can easily recognize. Even if you think at your colleagues, students, you see that there are people that just blindly follow the mainstream. This is not advisable, especially for an engineer. And because the engineer needs to be always critical, and you know, the engineer has to be aware of uncertainty. So this means that even if something is given by the majority of people for true, the engineer should really make some critical assessment. Is this really true, or what is the uncertainty of that? You know, usually in any truth there is some uncertainty, and the engineer has to be aware of that. Communication, we know why it's important. I don't spend much words on that, but communication means also that when you make an interview, you can manage it. And don't think that this is something that that people, it's not in the genes, I mean, it's not inherited. Communication, the ability to speak, is something that can be really improved. And so don't underestimate the effort that you could do to improve your communication capabilities, because I tell you, it is something that really improves, and it improves with time, but if you make efforts, it improves faster. Collaboration means team working, and I think also in career life there is some mention to team working. Team working is also extremely important, and is something that sometimes I got this question: is this a person that is a good team worker? Because I need this person working in a team, and you know, and so pay attention also to this. And of course, to be good in team working also implies that sometimes you have to accept the opinion of others, and that you have to accept decisions that are not really something that you like. So, okay, digital literacy means that you are, as an engineer, you have to be very confident with the PC, with automatic calculus, with the software, with the programs, programming. Look, this is another quality that if you are good with the PC, again, it is much more likely that you are successful in finding a job. And there are very few people that can use a PC in a very efficient way. Everyone uses it, but there are some people that are very good. And the result is that they take half time to complete the job with respect to others. And this is something that is extremely important. Efficiency is extremely important also for your quality of life. If you can stop working 1 hour before, 1 hour in advance, you understand that every day you have 1 more hour to do whatever you like, to relax, to take some training, some sporting activities. And or you can deliver your work 3 days in advance with respect to your competitor, which is something that is much appreciated today. Career and life, flexibility, adaptability, self-direction, independency. Let me call it independency. And this is also a quality that is extremely important, to become independent, and especially in the university, when we make some selections for people, we explicitly look at the CV for independency. So evidence of independency. What does it mean, independence? It means that you don't need to ask advice for everything you do. You can solve problems autonomously, and you can manage a job autonomously. You don't need somebody telling you what to do. At the beginning, we are not independent, but during our career, we need to become independent. And social cross-cultural interaction, productivity means efficiency. Accountability means that you are accountable. To be accountable means that you make your best to give the possibility to your boss to check your work. Okay? And leadership and responsibility. Leadership is another thing that is extremely important, which means that you don't have to look pretentious. When you make an interview, you have to be very careful not to make a TV show, okay? And not to look too pretentious. On the other hand, you have to express leadership in an humble way. Leadership means that you are not concerned by responsibility. You are not concerned by managing people. So if you have to manage 10 people, fine, this is perfect, it's nice, I like it, and this is leadership. Or leadership means that you can really carry out a difficult job. Okay, I think that during these times we know what leadership is, and we have also good example of bad leadership. I mean, people that cannot manage well. Okay, so just try to pay attention and. Look, most of these qualities, some people say it's a matter of experience. No, and it's a matter of experience is something that I don't like. It's a matter of effort, not experience, because if you don't make effort to improve, you get old, and you don't improve, even if you have a lot of experience. So it's a matter of effort. A person that makes efforts become expert in 1/10 of the time with respect to a person that doesn't make efforts. So it's not really, because it's a matter of experience, it's sometimes something that is used to keep the young people out of the game, you know? Like, oh, this is a game for old people, this is like, in politics it happens, she's too young. I mean, it's not really, it's something that I don't like. Okay. So, what is the result in practical terms? In practical terms is that, let me go back to my webpage for us. In practical terms is that this is the learning scheme that I would like to use. There is a classic scheme that starts from the theory, and then from the theory to models in engineering, I mean. Model and then design variables and solutions by using data. I would like to focus on solution first. So the solutions that we need, we have only 12 hours, so I cannot give many examples of what I mean with this. But in teaching, I really would like to start from the problems, the solutions, and then, of course, if I need some theory, some models, then I pass to the study of the theory and the models. Because really, I think that if you look at the past 20 years in engineering, the means have increased a lot. 20 years ago, the PC was something that most of the students couldn't use. Most of the students didn't have any email. Most of the students didn't use the web. 30 years ago, nobody was using the web. the PC, or I started browsing the web in '93 after my degree, and it was 30 years ago, and I tell you, I was one of the first. The email, I was one of the first. I started in '93 using the email, and when nobody was really using it. So we got a big progress. It's a radical change. But if you look at the products, at our methods, solutions, there was not a corresponding increase. There was not a corresponding change. So when we look at the design methods in engineering, we still use books that were published in the 90s, 30 years ago. So what is the reason why it is slow moving, the process of moving from increased means, increased data, moving to solution is a slow process. Why? Because I think that we are still missing the final step. The final step, how to use this data, how to use these means, how to use the additional information, how to convince people, because today communication became really very important. So I think that probably we need to focus more on solution, more on what we need, and then, of course, in theory, but not as a starting point. So this is my view, and I think that now we can close this lecture and pass to the second one, and then start to talk about beaches and coasts. Sorry. Okay. I like this picture, and it's in Wikipedia. Let me put it on the screen. What is depicted here? These are landlocked countries, the landlocked countries. These are the countries, the 48 countries in the world that don't have any access to the sea. And these countries are indeed disadvantaged countries. I like this picture because it shows that the sea is a resource, but it is an important resource. It is something that is really a plus in terms of trading, in terms of tourism, in terms of transport, and resources like fishery, like access to gas, etc. The landlocked country, they are 48, as I said, and they are only few because indeed the countries try to organize themselves in order to get access to the sea. And if you look at the modern history, some of the wars are caused by this very reason, gaining access to the sea. Some wars are caused by gaining access to water, to gas, to energy, but also sea is extremely important. So this is why I indeed like this picture, which allows me to give you some numbers, and I am PowerPoint, sorry, which is much better than using this. The PowerPoint can be downloaded also by you, but don't use it for studying. It's good for maybe for some refreshment, but not for studying, because it's a very condensed synthesis. Okay, so first of all, what is the coastline? The coastline is the transition between the land and the sea. Okay, it's the boundary. And conventionally, we say that it's located at the high tide mark of the sea. So the coastline is located where water gets when there is high tide. Okay, and the coastline, the socioeconomic value and ecological value is given by some numbers. The coast areas occupy less than, let me say, 15% of the Earth's land surface, but more than 40% of the world population is living there. And in fact, about these numbers are already old, 4 years old maybe, they are for sure increased. more than 1 billion people live within 100 kilometers of a coastline and 100 meters of altitude above sea level. And with an average density which is about 3 times higher than the global average for population. So most of the people live there. Not most, but a density 3 times higher of people lives within 100 kilometers from the coast. And in Italy, this is even more appalling because it's about 60% of the total population that lives in coastal area. And about 24% of the population is living in big coastal cities. So these numbers, which you don't have to remember by memory, of course, but give you an idea of the importance of the seashore as a resource for any country. This is why we are focusing on coastal engineering. So the coastline, I want to tell you a curiosity. You may be interested in knowing for a country the coast length area ratio, which means that you get Italy, you measure the length of the coastline and you divide the length by the area of Italy. This is an important parameter because it tells you what is the length of the coastline, the relative length of the coastline with respect to the extension of a country. But there is one nice paradox that the length of the coastline is impossible to measure. Why? Because it depends on the scale to which you look at the coastline. And if you increase the scale, the coastline becomes more and more complex, more and more articulated, and the length increases. And in fact, I don't know, I'm not sure if you know something about fractals, the fractal theory, which means that if you look at a figure of whatever, like a cloud or the coastline, and you zoom it, the shape remains unchanged. This is called scale invariances. So the coastline was proved to be scale invariant, which means that you zoom, zoom, and zoom, and the shape remains the same, which means that the length is unmeasurable because, it depends on the scale of representation. This is called the coastline paradox, but of course, if you fix the scale, you can compute this length area ratio, which is an important parameter for a country. And I think we can look at it. There is the link. I go back to my web page. Sorry. I think there is a link here. Let me see. Length. Here. A list of countries by length of coastline. You see, this is a representation of the coastline paradox. And there is also a link in Wikipedia. And here is, there are different computations for the coast area ratio. And the World Factbook or the World Resources Institute, they computed two different values, and I think that the difference in numbers, there are some numbers that are very different indeed. But if you look at individual countries, they are quite similar. So Canada, this is the list in orders of decreasing ratio. So Canada is the country that has the length, the highest length of coast, Norway, Indonesia, Russia, etc., etc. Italy, etc., etc. Italy is quite in a good position. This is just a curiosity, okay? So we are interested in protecting the coastline. Why? Because of its importance. So we are interested in preserving the coastline. We are interested also in taking the best in terms of resources from the coastline and from the sea. And keep in mind that preservation and exploitation of resources may be contrasting needs. Because, of course, on the one hand, if you want to really preserve, you should avoid human intervention on the environment. On the other hand, if we need to exploit resources, we need infrastructures, and infrastructures, or in any case, we need to use these resources. So there might be contrasting needs, and this is the reason why this very exciting term was coined, sustainable development. Sustainable development means reaching a good compromise between preservation of the environment, so the resources can be preserved for the future generations, and exploitation of resources, which are necessary for development. So sustainable development means a compromise between sustainability and development, which is something that is very important because both the extremes are extremely dangerous. If we exceed in preservation, we expose ourselves to risks, and the results are like the flood that unfortunately today occurred close by here. This may be, I'm not sure, but may be that we exceeded in preservation because we need infrastructures to protect ourselves from floods, from coastal floods, from fluvial floods, etc. On the other hand, exceeding in overexploitation of resources, it's a tremendous mistake because it can cause other disasters. So, for instance, a flood may also be caused by the fact that we didn't respect a river, like we got too close. We subtracted to the river the vital space. So reaching this compromise means that we don't have to avoid infrastructures, we don't have to avoid intervention, but on the other hand, we have to carefully study the implications on the environment and maybe avoid some of them. And the best solution depends on the local context, depends on the nature of the problem, and finding the best solution, it's your job. It's a job for engineers. So we are interested in protecting the coastline. We are interested in developing in a sustainable way the coastline. So we need to know the processes leading to the evolution of the coastline, to the formation and evolution. We need to know the coastline processes, the coast processes, the sea processes. We need the theory behind these processes because we want to find the solutions. And so what are the drivers that shape the coastline? The main drivers, it is, first of all, let me say, it's a complex interaction of drivers. It's a continuous confrontation between the land and the sea. And this confrontation is driven by climate. Of course, climate is providing the energy for that. And this confrontation, what are the actors of this confrontation? What are the soldiers? They are the fluvial deposition, because we have sediments coming from the land. And on the other hand, another soldier is erosion. So the river is bringing sediments, and the sea reacts by eroding. But not because they want to fight, because it's a matter of finding an equilibrium. It is very simple. So if you have a system that is more or less in equilibrium, and nature is more or less in equilibrium, unless some shocks happens, like a volcanic eruption. So soon after a flood, a big flood or a volcanic eruption, you have a situation that is not in equilibrium. But nature tends to establish an equilibrium. And so if you have a system that is more or less in equilibrium, and you include a perturbation, like a shock, or like fluvial sediment transport, the system reacts by trying to compensate, reestablishing equilibrium. So if you have fluvial deposition, you have erosion. You have erosion by the sea. If you limit the fluvial sediment transport, like we did here, then erosion prevails. Okay. What we did here is that we extracted the sand from the rivers in the end of the past century because we needed sand for buildings, for roads, etc. And then the erosion increased. And it would increase until a new equilibrium is reached. But to reach a new equilibrium means that you reach a new configuration, a new shape. So we have to understand these processes. And of course, it depends on the type of coast, because in a coast in a coast that is dominated by an alluvial land, a coast that is corresponding to an alluvial land, like here. Alluvial land means a land that results from deposition. Then erosion is extremely important. Erosion, sediment transport are extremely important. If you have a cliffed coast, its sediment transport is less important. So we have to understand these processes, how they evolve. Okay, I think I can make the break now, and I leave the video running because otherwise I run the risk of forgetting to restart it. So in the video you will find also the break, but I close the mic so you can comment on my lecture as I go for a coffee. And I close also the video.
giusto andare in gite, ci sono due parcheggi, sono grandi. Però
In Alaska,
sì, io forse sono la stazione all'inizio di la strada che ti porta qua, all'inizio dove c'è la Vermina, non so se è presente, all'inizio sono due parcheggi, uno è nascosto dietro, ma un po' di c'è un altro dall'altra parte della strada che si vede.
Okay.
No, posso fare una domanda?
Yeah.
Dove lasciano?
I come by train.
Ok.
I follow your discussion. Yes, I came a couple of times with the car and I paid the park. Yeah.
Okay.
No, unfortunately, I don't have. But I'm not from here, so you should ask somebody from Ravenna.
Yeah. Maybe near the station.
Okay, so let's talk about the classification of the coastline. There is a huge literature, because why classification is important? Because by classifying an environment, you also identify the processes that are contributing to shaping it and are contributing in general to its evolution. And there are different criteria that can be used for classifying any environment. For beaches, there is a traditional distinction between descriptive and the genetic criteria. The descriptive criteria look at the shape, at the conformation of the coastline, at the geometry. The genetic criteria look at how the coastline has been formed. So let me give you a couple of examples. Let me start with the descriptive criteria. For instance, the distinction, the division between cliffed coasts and flat coasts, it's an example of a classification according to a descriptive criteria. Actually, this division between cliffed and flat, it's extremely important because it splits the coasts in two very different categories. The flat coast is typical of alluvial lands. There is a smooth transition in terms of slope between the land and the sea. And it has been originated typically by deposition, the flat coast, and the slope is mild. The cliff coast is typically originated by tectonic activities, so the emergence of the land or the lowering of the sea level or the increase of sea level. And the cliff coast is characterized by an abrupt transition with a vertical transition in some cases between the land and the sea. Typically in the cliff coast, you can identify small beaches, small portions of flat coast, typically at the mouth of the rivers. At the mouth of the rivers, you have a kind of flat coast that is embedded into cliffed coasts. The flat coasts are, of course, easier to be used for recreational purpose and also for commercial activities. But also there are examples of cliff coasts where very important ports are located, like Genova. Genova is an example of a coast that is mainly cliffed, but still you have this port, which is one of the most important of Italy, one of the most important of Europe, that is located there. So what are the beaches? Because we still didn't define them. The beaches are defined as accumulations of loose sediments of varying size and type, and the shape of the forms of the beach are mainly determined, as I said, by the confrontation of depositions by the river and erosion. Don't be surprised if you can find beaches also far from the rivers, like for instance here in the Mediterranean, in the Adriatic Sea. The main supply of sediments comes from the Po River, but then the sand, which is a very fine, the grains are very small, it's transported by the sea currents also at a long distance. So it means that indeed the sand that you find on most of the beaches of the Adriatic Sea between Venice and Ancona is delivered by the Po River, and in some cases it may also travel beyond Ancona because the sea currents may transport the sand at a long distance, especially if there is no protection on the beach, and therefore the erosion and the transportation of the sediment is not mitigated. As I said, the size of the grains is very variable. It depends on the type of beach. It depends on the type of sediments that are delivered by the rivers. So on the Adriatic Sea, the size of the grains is very small because the sand delivered by the Po River is a very, very fine sand. It is something that is quite infrequent. And it is like that because the Po River is a very long river, and it has a downstream part that is very long. So when the sediments are eroded from the mountains, they have different size. But then the larger sediments settle down as soon as the slope of the river is reduced. And the larger sediments are the first ones that settle down. But then if the river goes on in its course, then the dominant sediments, the dominant size of the sediment is very small, and the large sediment don't dominate anymore. And for this reason, the Po River delivers a lot of sand to the Adriatic Sea. It only delivers sand; it doesn't deliver big boulders. Another criteria of classification, and this is a genetic criteria, divides between emergent and submergent coasts. So the emergent coast is originated by an uplift of the land. The submergent coast is originated by a sea level rise. After the last glaciation, which ended about 12,000 years ago, there has been a very important increase of sea level, more than 100 meters in the Adriatic Sea. And therefore, it follows that part of the coast was submerged, part of the original coast was submerged, and you can find in several locations many examples of submergent coasts. So, for instance, if we want to give an example of emergent coast, we can look at the western part of the United States, where the tectonic uplift, indeed, it's a very active area in terms of tectonics, as we know. And the uplift has originated some emergent coasts. Conversely, on the east part of the United States, there is a very famous beach, which is the Chesapeake. I don't know how to pronounce it, but it is the Chesapeake Bay, which was originated by a sea level rise after the last glaciation. And this is a very important area for an environmental point of view, from an environmental point of view. And it is a very important example of an environment that is an enormous value. And in fact, they are protecting this area with enormous efforts because the ecological value here, it's really an area where there are some rare species of fishes and wildlife live. And there are also some examples of ecologic emergencies that are very, very important. And if we have time, I will show you a video on the preservation of this area, because they are really making important efforts.
Sorry, you need to understand the difference between emergent and submergent.
Okay, so basically, the emergent coast is originated by an uplift, a tectonic uplift. So if you have the land that goes up, then you have a part of the coast that was originally submerged that now is emerged. Conversely, if you have the sea level that goes up and then gets here, then here you get a submerged coast.
It can vary with time in each.
Yeah. Yeah, it can, you know, they are different processes usually. So the tectonic activity and the sea level are governed by different processes. So they are not related to each other generally. So I don't think we have examples of, but yeah, they may overlap. For instance, I'm not sure if in the eastern United States they had previously an uplift, and then, so I'm not sure if we can find example of coasts that were submerged and then now they are emergent.
Well, because I'm asking because I'm from Kazakhstan, we have Caspian Sea over there, which varies in water level. Okay. Because such issue over there and its effects on.
Okay, I see. This is interesting. Also, there is to say the time scale of the two processes is different. Let me talk about the sea level rise, because the sea level rise is very popular, because you know that now we are in a phase where the sea level is rising, but to give you an order of magnitude, from 1850 to today, the sea level rise is about 15 centimeters at the global level, average at the global level. There are hotspots where there are differences, but on average it's 15 centimeters. But from the last glaciation, which means 11,000 years ago, it increased about 120 meters. But the tectonic activity, I think it is taking place on longer time scales. I don't think the time scale is like 11,000 years. I'm not an expert, but I think it is longer. It is even longer. And it is also important that you take into account the difference between the recent sea level rise, 15 centimeters in 150 years, and the sea level from the past, the last glaciation. Actually, we are still in the tail of a glaciation. So the last glaciation, we say that it ended about 11,000 years ago, but actually the temperature is still lower with respect to the average on the very long period, like 5 millions, last 5 millions of the Earth. So technically, the geologists say that we are still in the tail of the last glaciation. And, but of course, being in the tail means that there is a natural variability of temperature that is still increasing in the long time scale, which caused this increase of sea level of 120 meters, because you know that the glaciation means that the glaciers were much more extended and the polar caps were much more extended, also including a larger volume of ice. But in these long-term changes of temperature, we can identify smaller scale fluctuations in terms of time. So, for instance, we know that in the Middle Age, about 1300, there was a climate optimum with a warm temperature. 1700, there was what is called the little glaciation. It's low temperature. And then from 1750, we are in an increasing phase. And then there is climate change. Climate change, we conventionally say that the human influence on climate change, it is a broad term. But today, when we say climate change, we usually imply that it's the human-induced change. So this human-induced change, it's conventionally, we say that it started after the Industrial Revolution, which means after 1850. And in particular, you know that in the past 30 years, there have been a larger increase in global temperature. For sure, now we are in a period of warming. This is something that is clear, okay? And this warming started in 1750 and accelerated in the past 30 years. And the acceleration in the past 30 years is likely to be due to human activity. And even if there is this combination between natural variability and human influence, that it's not fully understood. There is uncertainty. But on the fact that we are in a warming period, there is no discussion. And the scientific community really agrees and it's consensus. On the implications on sea level rise, this is still something that there is uncertainty because the sea level rise, as I said, from 1850, it's about 15 centimeters, but there has not been acceleration in the past 30 years. And it's not yet clear if there is a delay, maybe. But if you look at the graph of sea level rise, I have something to show. We don't see an acceleration in the past 30 years. And keep in mind that the sea level rise is due to two components. It's ice melting and thermal expansion of water. And the thermal expansion is a significant component. It's not negligible. Okay. Beaches are very important. I'm not spending much time on this because we know why. And what I want to emphasize here is that the equilibrium is very delicate. So the equilibrium between use of beaches and protection of beaches is very delicate. So if we want to protect, we should avoid the access of humans, of people, and leave them not accessed. But of course, this is implying two things. First, the commercial use, of course, it's not possible if you don't give access to people. And one could say, okay, but who cares? I mean, it's most important thing is to preserve the environment. But the second thing that I would like to say, keep in mind that at the local level, it is not granted for sure that if we leave something unattended, the evolution is, according to natural forces, is protecting the same environment. At the local level, it's not granted for sure. And the very significant example, if you look at mountains, and if you allow them to evolve in a natural way, then it means that some events, some shocks, which change the environment in a very significant way, are more likely to occur, like big landslides, for instance. If we don't protect the environment, if we don't protect the hill slopes, then big landslides may occur. And these events are shocks also for the environment. There are some environments that were lost for natural causes. And, you know, if you look, for instance, at Mars, it's given for sure that it was a planet with water and with some forms of life. We don't know if there were intelligent form of life, but it's clear that there was water, there was some form of life, and the natural evolution brought the life on Mars to disappear. And so the natural evolution is not always protecting the environment. So leaving a beach unattended may not be the best solution, especially after a perturbation at larger scale. So today we intervene in order to limit the beach erosion. If we didn't intervene, and the beach erosion is caused by the limited supply of sediment of the Po River, because we built dams, we also remove the sand, etc. If you don't protect the beach from erosion and you leave the beach unattended, this is causing probably the death of the beach. So this is also a myth that we have in a way to examine critically. So nature, it's not always protecting itself, especially after perturbations, okay, after shocks. And so, I mean, this equilibrium is a very delicate compromise between preservation, between use, and there is not a universal recipe. We cannot just say, leave it unattended. It depends. It really depends on the context. And this fact that it depends, it's really something that, as engineers, we have to try to make better known. Because today, the tendency is to agree on universal recipes, but the dependence on local conditions is extremely important. And the same for floods, the same for other natural hazards. Okay, but just keep in mind that I may ask a question like, why beaches are important, and try to be prepared to give a convincing reply to that, okay? And, also when you go for a job interview, you have to be prepared for questions that may be not very quantitative. Sometimes one expects in a job interview questions that aim to inspect your ability to make computations, to make calculations, or your knowledge. Okay, so some people like studying books, and because if they go for an interview on a specific job, they study the theory related to this job, the books. But then a question may come like, what do you think are your strengths? And what do you think are your weaknesses? You have to be prepared also to questions that are not really quantitative, but require a narrative approach. Okay, the reply requires a narrative approach. So I may ask something like, why do you think beaches are important? So you don't need to study this, but you need to get the pulse of the environment you are studying. So you have to understand how beaches are formed, how they evolve, what are the processes, why they are important. Okay, and let me talk about the ecology of beaches, because beaches are very often considered like a desert environment. Why? Because for the presence of salt water, there is not much vegetation close by to the sea. Actually, if you leave the beach unattended, you get the vegetation that gets very close to the sea. Our beaches are attended. Our beaches are, in a way, modified, and therefore, sometimes the vegetation is brought back, or the beach is pushed forward. So there is a long distance between vegetation and the shoreline. Actually, if you leave it unattended, or if you go on some beaches of the Adriatic Sea that are not commercially used, so they are the so-called free beaches, you see that the vegetation is more visible, okay? And usually it is removed when they are used for commercial purposes, because the vegetation is sometimes is inconvenient for a commercial use, and the vegetation is also implying some problems, for the people to reach the sea. But so this is also one reason why they are considered desert environment. There is salt, there is less vegetation, and you don't see many big animals on the beach. But on the other hand, there are many forms of life that live on the beach. Some of them are buried in the sand, and some of them are very small. But there are many forms of life, also many forms of phytoplankton, macrofauna, vertebrates, and also keep in mind that shorebirds are frequent populators of the beaches, and so the ecology is really important, and very often the commercial use of the beaches limits the expansion of this ecological life. It's in a way undermining the ecologic equilibrium. And it is interesting if you go to see some, as I said, unattended beaches, especially during the winter season, you can understand how many forms of life you can find there. And definitely a visit to the beaches during the winter, take the opportunity, because it's also interesting to see how commercial beaches are managed during the winter in order to protect them. It is interesting. We will have time to discuss this. We will, I think, we will discuss explicitly about saltwater intrusion, but I am not sure, so I want to give an anticipation to you here. As I said, close to the beaches we have salt water. And the salt water may be in the forms of surface water, so water that comes from the sea, is the wave run-up, okay, along the so-called swash zone. So the wave run-up is the zone that is covered by the run-up of the wave and the run-down. And this zone that is alternatively wet and dry, subjected to the wave back and forth, is called the swash zone. We will see some terminology later on. So, there is surface water, there is water in the form of spray. When the waves break, and if there is wind, a spray is originated, transported by the wind, and it may move inland for a considerable distance. And there is salt groundwater, because in the beach, the soil is permeable. Okay, beaches are made by loose material, loose grain, loose depositions, and therefore they are permeable. This means that the seawater intrudes into the land. And how long does it intrude? If there was no competition with any other water in the underground, the intrusion may go on forever. Because, you know, on the one hand, you have here the sea that is pushing salt water into a permeable soil. And therefore, in a static situation, you may get the salt water that goes into the land forever. But into the land, you have fresh water that is flowing toward the sea. And you always have fresh water into the land. Why? Because you get rain over the land. Rain, okay? And this rain infiltrates. There is infiltration. Why infiltrates? It infiltrates because the soil is loose, it's permeable. Of course, if you had a rocky coastline, it would be completely different. But we are talking about beaches. So you have rain, and rain is over the land, it's at a higher elevation. So you have infiltration. So you get water here, which is at higher elevation. It's higher elevation because the land is above the sea. And therefore, this water tends to flow towards the sea. This is unavoidable. And it's a lucky situation. Because then there is a competition between, competition between the salt water that tries to intrude into the land and the fresh water that needs to flow towards the sea. And in the rivers, you have a similar situation. In the rivers, in terms of surface water, you have fresh water from the river that goes into the sea, and this is unavoidable, of course. But, on the other hand, you may have situations where you have waves from the sea that push the salt water up along the river. And in a river, you have this confrontation. And what happens in a river? You may have heard what happened during the summer along the Po River. We had a drought that was unprecedented. in July. Unprecedented, absolutely. We still don't have the numbers, but I took the numbers myself from, they are available from the website of the Regional Protection Agency. And I got the opportunity of get the same numbers back to 1807, because there is one of my colleagues who reconstructed these ancient flows of the Po River. Of course, there is uncertainty. When you look at numbers that were collected 200 years ago, there is uncertainty, because you don't know how they were collected, etc. But still, if you compare these numbers, and numbers I mean the average Po River flow in July, this was unprecedented in 2022. It was incredibly, amazingly low. So it means that the strength of the Po River flow to go into the Adriatic Sea was reduced, and people reported that the salt water intruded for 30 kilometers upstream. And this never happened before. And I believe that, because it never happened before that the Po River was so low. Before, when I say before, I mean in the recent past, okay? Because even if you go back 2 centuries for a river or for a natural environment, it's a very short time, okay? And so there is this continuous confrontation, which also happens in the underground. In the underground, it's a bit more problematic because it is more difficult to observe and everything is slower. The flow is slower. So when you talk about river flow, no, sorry, water flow, not river. When you talk about water flow, you have to be very concerned when the water flow is important and slow. Important in terms of volume, for instance. So groundwater, it's very important for us because it provides a lot of the water that we need. But the flow is slow. What does this mean? It means that if you make a perturbation there, and the perturbation may be overuse or maybe contamination, it takes a lot of time to restore. Because if you have a flow that is very fast, then it doesn't take much time. And this is why, for instance, we are not concerned by river pollution, or we are concerned, but we are much more concerned by groundwater pollution and lake pollution. For the lakes, the same situation. In a lake, the change over time may be centuries. Okay, so if you get pollution into the Lake of Garda, how long does it take before you remove it? Maybe 100 years. In the groundwater, it may take 1,000 because it's very slow. So this saltwater intrusion in the underground is very concerning. And there is a huge part of coastal engineering that is studying how this shape developed. And you may wonder why the saltwater intrusion has the form of a wedge, okay? And the reason is very simple. The reason is that as you go inland, the height of fresh water increases. You see the line of fresh water goes up, of course, because the altitude of the land increases. So the fresh water pushes down with a larger height, has the strength to push the salt water down. And there is a lot of research activity and modeling activity on the study of this wedge, because here there is a strong assumption that you can understand from this video, that the transition is abrupt. It's not an abrupt transition. There is a mixed zone that is very difficult to identify the contour. This is a fascinating problem, very important one. Maybe that we have time to discuss together this, but now let me go back to the issue of understanding how the coast and the beaches in particular evolve. We need to know this because, as I said, we need to preserve this environment, we need to use it. Let me use the term use, which is not elegant. Let's say we have to be able to exploit the resources. And in order to study this compromise, you understand why the role of the engineer is important, because we need to understand their dynamics. We need to understand how they combine. And this is not easy. It's not easy because you can easily get that sediment transport by river is already a complicated process. It's the energy of waves, it's a complicated process. The interaction between these complex environments is still a mystery. And there is one thing that I want to tell you. We have today the feeling that we understand everything of the Earth system and we can predict everything. We are engineers, we have to be aware that there are many parts of the Earth system that are completely unknown. Even the simple thing, which is river flow, we have still a lot of uncertainty, still many things that we don't know, how the river flow forms, why some floods get humans by surprise. Why? Because it shouldn't be that. If we understood everything, then the implication is that we should be able to predict everything. Instead, the problem is that our knowledge is still limited, and this means uncertainty, which is normal in science. It's normal in natural sciences. It's normal. But today we have this problem that the public and also some administrators don't realize that there are several unknowns, so they don't see the need for research. But, which is even more problematic, also they don't understand uncertainty. So they expect that in a way we can predict everything. Unfortunately, we don't have this capability. And therefore, it is extremely important to get the meaning of uncertainty. And this applies also to climate or to meteorological predictions. Sometimes people think that if a storm happens, some people comment and say why it was not predicted. And they imply that there was a fault somewhere. Very often there is no fault. There is still the fact that some processes, either we don't understand them, we still don't understand them, or even if we understand, we cannot predict, because the evolution is chaotic, the evolution is unpredictable. Okay, this doesn't mean that we don't have solutions. We have solutions, but the solutions need to take into account first that there is uncertainty. Second, that any solution has a cost, and therefore a social cost, and therefore sometimes if we don't put solutions into practice, it's simply because we don't have the resources to do that. Okay, so we need to study this branch of science, which is called coastal hydrodynamics. Hydrodynamics is clear, the dynamics of the movement of fluids, rivers, waves, coastal hydrodynamics and morphodynamics. Okay, here you can read on this slide why the problem is difficult, and spatial and temporal scales, they are different, and also, you know, observation is a problem. So observing these processes is a problem. Even an easy variable like wave height, sometimes it's difficult to measure. We will discuss about monitoring, but it's some of the variables are not easy to monitor. Okay, so let's get into this topic, and let's see, we have like half an hour. I anticipate that this part of our discussion together becomes, within a few slides, quantitative. Some math will get into the slides, and so it is something that is not really very easy to understand, and so let's try to discuss together, and please let me know if your background doesn't allow you to understand some parts, we can dedicate time to this discussion. Okay, and so I think you already studied wave dynamics. No. Okay.
Electromagnetic.
Sorry?
In physical world.
Okay.
We know what's a wave, but not very low.
Okay. So, but you know, usually I started teaching here in the month of November. And I used to give wave dynamics and wave dynamics given for granted. And I cannot anticipate it because I think that, okay, Professor Ronchetti will do that, and Professor Bratt also, because given that you have a different CV in different study plans, they both need to do that. And so I don't want to do that myself. In my website, you can find a web page dedicated to wave dynamics, but I think I can teach this part even if you don't have any knowledge of wave dynamics. I just introduced some terminology, okay? Yeah.
Sounds clear.
Yeah, this one is clear, okay? And yeah, so you will study in detail wave frequency, wave period, wavelength. So the terminology, I think that it's not necessary that I give it in the that I go into the details. I just want to say one thing, to anticipate one thing that you will study with Professor Ronchetti. For studying beach hydrodynamics and morphodynamics, what are the design variables? Okay, the design variables in terms of waves. So what are the design variables that I need from the seaside? And these design variables are the extreme wave height, and wave height is given here, you see. It's the difference between the through and the crest of the wave. The through is the lower part of the wave, the crest is the upper part. So, and the wave height is this difference. And so I need to know this quantity, and you will distinguish between wave height and wave amplitude. Amplitude is half of the height under certain assumptions. And so I need the wave height, I need the wave direction. And what else do I need? I think it's okay. Because I don't need wave frequency, I just need wave height and wave direction. Maybe also, yeah, maybe I also need to know the wave frequency or period, but you know already, because you are already at the master's degree program, so I think you know that the period is the inverse of the frequency and vice versa, but the period is the time distance between two crests. And in doing this, in talking about in using this terminology, I am implying that I'm referring to only one wave, which is not the case in the coasts. Usually we have several waves that are interacting each other, but here I am referring to the assumption of what is called plane wave. You will study it in detail, which means that I refer to only one wave, like in this picture, okay? And only one wave means that I have only one height, only one period, only one direction. Because I talked about, I need to know the wave direction. So I imply that it's only one. Okay? And so I defer any detail to my colleagues. Just keep in mind that I work under the assumption that I have only one wave hitting the beach in only one direction, and with only one height, only one period. You understand that it cannot be true. If you have been on the sea during a storm, even a storm, not a significant storm, a mild storm, you see that if you try to identify the wave direction, you are a bit in trouble. But sometimes you can identify a dominant one. Okay, let's assume that this dominant one direction is just a law. And the dominant wave, sometimes you can identify the dominant direction and the dominant wave coming from there. Let's assume that it's only one. It's an ideal situation. Good. Let's move forward. Okay. Now, let me go to the next lecture, but before going to the next lecture, I want, let me see, to show you a video, because otherwise it becomes boring. Because this is the next lecture, so one thing, I want to get a video, let me see where is, because I know that there is a video somewhere. Okay. Yeah. Okay, let me show you this video. It's short, but I don't want to become boring, so I think it's better to understand, to see what happens, the position and erosion. So what is this video? I want to anticipate what is it, because otherwise if you start watching, then you don't listen to me anymore, which is understandable. So the first part of the video is 2 hours, but it's accelerated. It will be like 30 seconds of waves in a flume. You know what is a flume? It's what is called in Italian canaletta in a lab. A flume is in a laboratory a small facility that is trying to reproduce a part of a river or a beach. You will understand when I show you the video. And so inside this flume, waves are generated, and they go into this small channel in the lab, which is a regular geometry, which means constant slope, and the walls are vertical of the channel. And the waves have a period in the first part of 1.3 seconds, and these waves are steep and produce destructive forces on the beach slope. What does it mean? There is erosion that is dominant. Okay? The beaches, I think this plural should be removed. I don't know. But let's say the beach's response is to flatten out, and does this by slowly eroding the berm, which is part of the beach. You will see what the berm is. Okay, so the dry portion of the beach is the berm. It's eroded by these waves, which are very strong. Okay. Okay, so the eroded sediment is then transported offshore. Erosion means that the sediment is taken by the beach and brought into the sea. And let's see what happens. Okay. The second part of the video, the wave period is changed and the height kept roughly the same. So we have longer, more gradual waves for 3 hours and 15 minutes. And in this longer period, the wave produced constructive forces. What does it mean, constructive forces? The sand is brought back from offshore to the beach. So there are two phases. One is erosion. The sand is taken from the beach to the sea, and then there is constructive forces. The beach is constructed. The sand is taken from offshore and brought to the beach. Let's see the video, okay? Before I start, just 1 second, let me put it full screen. And let's go. Okay, this is destructive forces. You see that the sand is taken from the beach and goes out. Sorry. You see this one here. This is the dune. What is the dune? It is a deposition of sand, and you may ask, why deposition? Because there is erosion, and why the sand accumulates there? Why? Because it is the point where waves break. You see, the breaking of the waves is here. Where there is the breaking of the waves, there is stagnancy of the velocity. The velocity, there is some turbulence, and the velocity, the average velocity of the flow is reduced. It is the backflow. The velocity of the backflow is reduced. And then there is deposition. And you can feel the dune when you walk in the Adriatic Sea, the typical shape of these beaches. You walk into the sea and you get the water up to maybe your hips. And then at a certain point, you feel that the water is going down. And then soon later, the depth increases suddenly. Precisely what happens here. Okay, let's move forward. Now it's going to change. It is close to equilibrium here. And now it is changed. Here constructive forces prevail. So by looking at this video, we understood what is the difference between destructive and constructive forces and what is a dune. Sorry, I wanted to see it again. Okay. Now, you understand also what is a flume in lab, okay? And of course, this is an ideal situation because the flume is very regular and you have only one wave, like our assumption, only one direction of the wave, and the slope is constant. The slope of the seabed is constant. So what happens in reality, it may be quite different because, you know, there are several waves interacting, but the general concept is this one. And also you understand that there is turbulence here. It's a process that it's difficult to identify, to describe, but we can make simplifying assumptions. And the simplifying assumption means that we may write set up a simplified model, which is fine because the simplified model allows us to understand how the process evolved. On the other hand, simplified means uncertainty, which we have to be fully aware of. Good. Now let me go back and let's see. Let's see also this animation here. This animation shows what happens to waves when they approach the coast. The process of increasing the wave height and increasing also the steepness of the wave is called shoaling. It is something that, if you like the sea, you know quite well. So the waves, when they come from offshore, increase in height and becomes more steep. Okay, this is called shoaling. Why we have shoaling? It is very simple to explain why. When the depth of water decreases, the interaction between water and the seabed, between waves and the seabed becomes more significant. Friction between the waves and the seabed becomes more significant. So there is a slowing down of the velocity of the wave. The velocity of the wave decreases for the friction. And therefore, if you have the front of the wave which becomes slower, and the oceans continues to push water, you have like a compression of the wave. And the compression causes an increase of the wave height and an increase of the slope of the wave. And then at a certain point, the wave becomes so steep that it breaks. And this is what is called the breaker line. The position of the break is not shown here. The position of the break is called the breaker line. And if you refer to only one wave, like in this figure, this is indeed a line that is parallel to the coastline. And along this line, you have the formation of the dune. What happens to a wave after it breaks? It happens that the energy of the wave, no, it is not correct what I was saying. It happens that the wave transforms from a movement of energy to a movement of water. The wave doesn't move water in open sea. It's just an up and down. You get the feeling that the water is moving because you see the wave that is moving, but actually, it's not water that is moving. It's not water that from offshore goes on the land. It's just an up and down. But after the break, you have a flash of water. So the wave is, as Professor Ketenbratt will tell you, it's a movement of energy. This up and down means that you have energy that moves from offshore to the coast. It's a movement of energy. It's not a movement of mass. I said movement of volume. Mass and volume is more or less the same thing, okay? If one professor of physics heard me saying this, it would kill me. But it's a movement of energy, not a movement of mass or volume. But after the break, you have a movement of both energy and mass. You have a flash of water after the break. So why the surfer goes to surf in the so-called surf zone that is close to the breaker line? Because they like the movement of water. They want to navigate on this movement of water.
So that is called the breaking point of the wave.
Yes, it's called the breaker line, but usually not the breaking point. Why? Because the wave is not breaking in a point. You know, the wave is a transversal extension. It's not concentrated along a longitudinal line. I'm not sure if it was clear what I just said.
Yes.
Okay. It's not a point, it's a line along the transversal direction. Keep in mind these terms, longitudinal direction of the wave. So if the wave goes there, this is the longitudinal direction.
Parallel to the shore.
It's not the longitudinal direction if the wave.
No, the breaking lines.
Yeah, the breaking line is parallel to the shore. As I said, keep in mind longitudinal direction, transversal direction, vertical direction. I hope it's clear to you what these terms means. So if the wave goes there, the direction from here to there is the longitudinal direction of the wave, which is the direction of the transfer of energy. Perpendicular to the longitudinal direction, you have the transversal direction, and the breaker line goes along the transversal direction, and then there is the vertical direction. Okay, and then I close by looking at this figure. This figure was redrawn by me because it was a nice figure on a book, but given that these lectures are open, I cannot use copyrighted material. And keep in mind, whatever you find on my webpage, it's open. You can reuse it. I appreciate the citation, but it's not important. The important thing is that it can be, everything you find here can be reused. Okay? It's Creative Commons. Okay, so let's have a look on terminology. So we already talked about the dune, which is not really, sorry, the bar. Did I call the dune or the bar? No, I called it the bar, correct? What is forming in the video? Just 1 second. Because I'm not sure if I made a mistake. So, this is the sea, and the accumulation that forms here, this is the bar. I'm not sure if I called it the dune.
Yeah, the dune.
The dune? Okay, no, it's called the bar. Sorry for that. And then, before looking at the figure, we have here the berm. The berm is located at the end of the swoosh zone. So the swoosh zone is this one. When the wave breaks, you have the run-up that goes up and then comes down. The backflow is close to the sand. The upflow usually is above it. And where you have the end of the run-up, you have the berm. And if you go inland, in the unattended beach, so natural beach, you get an elevation, which is the dune. Now, why the berm forms here? Because you have a deposition of sediments where the run-up stops. Because the sand is taken, it's allocated here, and then when you have the backflush, you have the erosion. But still, some of the sand is accumulated at the end of the run-up. And this is the berm. And this is clearly identifiable on a beach. Keep in mind that if you go on a commercial beach, they try to flatten down everything. So in order to identify these forms, you should go to a free beach. Usually, behind the berm, there is a small channel of water, of salt water. It's called the runnel. Now, how it's formed the dune? The dune is formed because at where the extreme storms go, so upper limit of the extreme waves, the extreme waves bring with them a lot of sand, because the extreme waves have a lot of energy. And keep in mind that extreme events are responsible for the main part of sediment transport in both rivers and beaches. So once that a big storm occurs, a lot of sand is transported at the extreme end of the wave run-up and remains there. And so the dune is built. The dune is extremely important. Why? Because it's a protection of the land. And the dune usually is so high that you have some fresh water collected there and some vegetation can grow up. And the vegetation protects the dune. It's an interaction. They are self-supporting, they are supporting each other. The dune by providing the fresh water and the vegetation to keep the dune there against winds, against extreme storms, etc. The dune is extremely important. So you understand these three forms, the dune, the berm, and the bar. They are expressions of deposition of sediments that are located where the wave breaks, the usual run-up ends, usual means that occurs on average, and the extreme run-up ends. If you look at this figure, please have an independent look at this figure. There are additional terms that are introduced. The next Friday, I will start from this figure, and we will discuss these additional terms. But if you look at the figure, you see the dune with the vegetation, the berm, and the bar. And also there is a further description of the offshore part of the beach, but we can look at it next week.
Sorry, why the vegetation as fresh water or the dune?
Because the dune is very high. It's like 10 meters high.
Okay.
And therefore, when it can collect the rain and keeps the rain there.
Okay.
And vegetation is very strong. It can survive even with a small amount of fresh water. But for sure, it's fresh. When you see vegetation, there is fresh water. And the vegetation that you find in the dune is not very evolved. It's brushes because they don't have much fresh water.
And what about the wind?
The wind,
from the formation of the dune?
the wind, it's a destructive force usually, and the dune is protected by vegetation. And we are concerned when the vegetation is not there because the wind brings the sand inland. Oops. Okay, I think we can close here. I see that there is a student, so see you next time. And you will get the link for the room of next week. The room will be different.
Okay, thank you, Professor.
Yeah, bye-bye. I will put the link in the chat, and also you will find it in my website. I think I can also send it by email. Can I ask you one thing, students? Can you register in Virtuale? Because I look at the participants in Virtuale to this course, and there was nobody today. So if you register there, I can use the mailing list of Virtuale.
The registration like with COVID for the presence?
No. In Virtuale, if you go under the course, it should be automatic from. You did it when?
I did during the lesson.
Sorry?
I did during the lesson.
Okay, but yeah, before the lecture. Okay. Okay, bye-bye.